Malaysia menyaksikan populasi diabetes tertinggi di Asia, juga antara yang tertinggi di dunia, sehingga memaksa negara membelanjakan sebanyak 4.4 bilion ringgit setiap tahun untuk tujuan rawatan berkaitan dengan penyakit tersebut.
Greetings, doctor. My name is Lingesh. So today I'm going to present about the problem statement of our project, which is the smart glucose monitoring system using Max 300 plus sensor. So the problem statement of our project is about the inconsistent and error-prone glucose tracking, and also the limited access to long-term glucose monitoring records. And the next problem statement about the side effects and the adherence challenges with diabetes medication, and also a lack of family support system in executing glucose meters. So from this problem statement, we are conducting some objectives that we are going to implement to our projects about to develop a blood glucose meter using a Max 300 3000 sensor, and also to integrate the glucose meter with an OLED display and SD card module to store data and show the real-time glucose level to the diabetic patients. And also, finally, we want to evaluate the project by the accuracy of the glucose level reading with the real-time data of the heartbeat rate and the SpO2.
Hi, Assalamualaikum. My name is HG11 bin Faisal. My matrix number is AE21047. So I will be explaining a flowchart and also connection detail. Okay, so for the flowchart, the system start by initialize all the component. It check if the system is ready. If not, it will be reset. Once ready, the OLED display will show the ppm, SpO2 and also glucose level. Then the system will wait for the finger to be detected by the sensor. If no finger is sensed, it will loop back to the display stage. When a finger is detected, the result is displayed. Data then automatically stored, and if button is pressed, additional information like medication intake, date and time is recorded. Process ends after storing all relevant data. Okay, so for the connection detail, we have glucose meter, use Arduino Nano as the main controller. And then we have a Max 30100 sensor to measure pulse and SpO2. We have a OLED display to show real-time result. And then data is logged into a SD card module for tracking. And then system will be powered by a 9-volt battery with a 2-pin switch for easy operation. Key connection includes 12C pins, which is SCL, SDA for the sensor and OLED. And we have a SPI pins for the SD card.
Assalamualaikum warahmatullahi wabarakatuh. My name is Alia Syafiqah binti Abasha and my number metric is DE210005. So today I'm going to present about an ABC analysis. So for the first one, N is stand for need. It's globally increasing diabetes prevalently and many patients requiring constant blood glucose monitoring for effective management. Approximately 18.3% of Malaysian adult population is affected by diabetes. Second one is A. A stands for approach, which is it utilizes the Max 30100 plus sensor for non-invasive blood glucose monitoring by correlating SpO2 and heart rate data, and features SD card for secure data analysis to facilitate trend analysis. And for the third one is B, stand for benefit. It's provide a real-time and continuous glucose monitoring without the discomfort the traditional inventive method. It's also enhance patient safety through caregiver notification. And the last one for NABC analysis is C. C is stand for competition. Is traditional finger prick glucose meter that inventive require consumable like test strip, and it's also continuous glucose monitoring CGM system that very accurate but expensive requiring to the professional needs. Thank you. That's all for me.
Assalamualaikum everyone. Today I will explain about cost analysis. As you can see in this slide, there's a table for every item that we use. So there are 10 items: CCSP module, Max 3010 sensor, RTC module, switch, PW switch, SD card module, Verabot, 2-meter wire, battery holder, and 9-volt battery. So in total, for every item, the total cost that we use is 105 ringgit. That's all for my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Dania Najwa binti Rosli, and I will explain for the STEEP analysis. So for the social, the Star Online reports that 18.3% of Malaysia's adult population are affected by diabetes. Thus, there is a need to develop a system that can assist diabetic patients. For the technological, with technological advancements, there is now a wide range of cost-effective sensors and processors such as Arduino, which is simplify the design process. Like we use the Max 30100 sensors for non-invasive glucose monitoring system. About the economic, by reducing emergency incidents related to hypoglycemia, this system can potentially lower healthcare costs. About the For the environmental, the system's non-invasive glucose monitoring technology helps eliminate the need for disposable testing strips, reducing medical waste. And lastly, for the political, the project could face regulatory challenges in terms of medical device certifications, ensuring the system meets health standards and securing approval. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Ramli Atlas Nurdin, number metric DE220180. Today I will demonstrate the video of our device. As you can see in the slide, there's a video on the left side. So this is our device. So how to use the device is the first step is press the power button to turn on the device. The second one is put your finger on the sensor below the LCD display. By pressing the yellow button, it will record your heart rate, SpO2, which is the oxygen saturation in your blood, and also the glucose reading. So for your information, the device will take around a couple of seconds to calibrate before giving the accurate value. As you can see in the display, the reading is 73 ml per minute, 95 SpO2, and 5.3 mmol per liter glucose. And for the last step, which is press the red button to record the reading time. You need to press the red button to record the time of the medicine take. By doing this, you can review back the previous reading in the SD card. That's all how to use this device. Thank you. As you can see in the slide, there's a video on the left side. In conclusion, this project we have achieved three objectives, which is blood glucose meter development. Professional blood glucose meter was built using the sensor to estimate the glucose level and SpO2 data. So, and the second one is integration with OLED and SD card. By integrates with OLED display for real-time monitoring and SD card for storage. And lastly, the accuracy evaluation. Glucose reading are consistent and reliable, meeting goal community health parameters for accurate estimates. And by this, we can say the system provides a practical solution for real-time glucose monitoring and data management for diabetic patients. That's all from me and our group. Thank you.